Good day everyone, I'm Engine Cadet Asufra Jason. Today, we will present the corrective action for common boiler failures that can lead to automatic shutdown alarms. We will discuss the root causes, indicators, corrective action, and safety precautions, and recommended steps from the maker's operating manual. Our goal is to understand how to respond quickly and properly when these failures occur. Learning objectives. By the end of the lesson, learners will able to number 1. Identify the common boiler failures and their causes. Number 2. Recognize warning signs and shutdown indicators. Number 3. Apply the corrective actions for each failure. Number 4. Follow safety precautions when responding to boiler's alarm. Number 5. Use markers manual to troubleshoot boiler problems.
Low water level failure is one of the most dangerous boiler faults on board ships. It occurs when the water inside the boiler drops below the safe operating level, exposing the boiler tubes and furnace surfaces.
Root cause: feed water pump failure, low feed water supply, faulty water level control system, leakages in boiler tubes or water lines. Indicators: low water level alarm shutdowns, rapid drop in sight gas level, feed pump running but no pressure increase, abnormal steaming sound from furnace. Corrective actions: immediately stop firing, secure fuel supply, check feed water pump and suction strainers, restore feed water supply and refill boiler slowly, inspect water level controller for malfunction, reset alarm and after water level stabilize. Safety precautions: never add water rapidly to a dry boiler, may cause tube cracking. Avoid opening manholes until boiler cools. Use proper PPE, gloves, goggles, and face shield. Maker's Manual Troubleshooting Guide. Verify feed water pressure within normal range. Check automatic water level controller calibration. Inspect low water cut-off switches. Ensure feed water valves are fully open.
A high water level failure happens when the water inside the boiler rises above the normal operating level. Reaching the high level is censored. When this occurs, the boiler automation system triggers an alarm and often shuts down the burner to prevent serious damage.
Root cause: faulty water level controller, feed valve stuck open, pump over delivery, foaming inside boiler. Indicators: high water level alarm or shutdown, water carry over to steam line, weak steam or fluctuating pressure. Corrective actions: reduce feed water flow, check feed valve for sticking, drain excess water through blowdown, inspect water level controller. Safety precautions: avoid excessive blowdown, stand clear of hot steam lines. Maker's Manual Guide. Inspect controller float chamber. Service automatic feed valve if staking.
Low steam pressure failure. A low steam pressure failure occurs when the boiler cannot maintain the required steam pressure for ship operations. This triggers a warning alarm. In severe cases, the burner may shut down depending on the automation design. Low steam pressure means the boiler is not producing steam at the rate needed by machinery or systems.
Root cause: burner malfunction, fuel supply issues, excessive steam demand, faulty pressure control. Indicators: steam pressure dropping below set point, burner cycling abnormally, fuel pressure alarm. Corrective actions: check burner ignition and atomizer. Ensure proper fuel pressure and temperature. Reduce steam load temporarily. Reset pressure control settings. Safety precautions: avoid manual bypassing of safety valves. Monitor flame viewports cautiously. Maker's Manual Guide. Inspect burner blower and damper. Verify pressure sensors are calibrated.
High steam pressure failure. A high steam pressure failure occurs when the steam pressure inside the boiler rises above the safe operating limit. This situation activates a high pressure alarm and usually triggers an automatic burner shutdown to prevent damage or explosion.
Root cause: safety valve stuck or late opening. Burner control failure. Steam demand too low. Indicators: high pressure alarm or shutdown. Safety valve lifting. Burner not modulating. Corrective actions: reduce firing rate immediately. Inspect pressure controller. Check steam line valve for restriction. Safety precautions: never tighten or block safety valves. Maintain distance from lifting safety valves. Maker's Manual Guide. Clean pressure transmitter lines. Adjust burner servo motor if needed.
Flame failure or loss of ignition. A flame failure occurs when the burner flame inside the boiler goes out unexpectedly or fails to ignite during startup. The boiler automation will immediately trigger a flame failure alarm and shut down the burner to prevent fuel accumulation and possible furnace explosion.
Root cause: fuel pressure too low. Dirty burner tips. Ignition transformer failure. Black air registers. Indicators: flame scanner alarm. Burner trips. Smoke emission before shutdown. Corrective actions: purge the furnace before restart. Clean burner and ignition electrodes. Restore correct fuel or air ratios. Replace flame scanner if faulty. Safety precautions. Allow required purge time. Never bypass it. Ensure ventilation before opening burner doors. Maker's Manual Guide. Check flame detector sensitivity settings. Verify ignition voltage output.
Low fuel oil pressure and temperature failure. This failure happens when the fuel oil supply to the burner is not at the correct pressure or temperature required for proper atomization. When the fuel oil conditions are outside the safe range, the boiler atomization system triggers low fuel oil pressure alarm, low fuel oil temperature alarm, burner shutdown.
Root cause. Fuel heater malfunction. Black filters. Faulty fuel pump. Incorrect viscosity. Indicators. Fuel oil pressure alarm. Unstable burner flame. Difficult ignition. Corrective actions. Check fuel oil heater and temperature controller. Clean or replace filters. Inspect fuel oil pump pressure. Switch to standby pump if necessary. Safety precautions. Avoid touching hot heaters without gloves. Maintain good ventilation for fuel oil system. Maker's Manual Guide. Monitor fuel oil viscosity settings. Conduct regular cleaning of strainers.
High exhaust gas temperature failure. A high exhaust gas temperature failure occurs when the exhaust gas temperature rises above the safe limit set by the engine or boiler manufacturer. This is a critical alarm because it indicates poor combustion, overloading, or potential engine and burner damage.
Root cause. Soot buildup in tubes. Poor combustion. Black flue gas passages. Indicators. Exhaust gas high temperature alarm. Smoke emission. Decrease heat transfer. Corrective actions. Perform soot blowing. Check burner for proper atomization. Inspect economizer cleaning cycle. Safety precautions. Conduct soot blowing at safe load. Wear heat-resistant PPE. Maker's Manual Guide. Follow soot blower timing schedule. Inspect air registers for fouling.
In a coal-fired plant, a bright yellowish-orange flame in the furnace is a positive indication that combustion is taking place properly. Anything that jeopardizes the combustion process jeopardizes the flame and also jeopardizes the safety of the people in the plant and the plant's ability to produce electricity. If the boiler flame goes out, you have only seconds to respond. In many cases, procedures will indicate that the first steps in dealing with a loss of flame are shutting off all fuel flow to the boiler and either maintaining or increasing airflow to purge the boiler of all combustibles. Unless action is taken immediately, the boiler could explode. When we discussed boiler explosions, we touched on some of the situations that can lead to a loss of flame. In this part of the program, we want to look at some other situations that have the potential for causing a loss of flame. What you can do to avoid a loss of flame. The indications available to you to verify whether the boiler is functioning normally or if a loss of flame has occurred, and the action necessary for keeping the boiler under control. There are a number of operating conditions that are common to a plant that have the potential for causing a loss of flame. One example is wet or frozen coal. During wet weather, rain or snow can increase the overall moisture content of coal. In addition to creating handling problems such as freezing and sticking, wet coal is difficult to dry and pulverize. In some cases, this condition can cause blockage in coal pipes, interrupting the flow of fuel to the burners. An alert operator should recognize operating conditions where there is a potential for a loss of flame and take appropriate action to minimize the chances of it occurring. In some cases, this action may require increasing the flow rate or temperature of primary air going to the pulverizer. In other cases, additional igniters or a warm-up burner may be used to ensure proper combustion. Another situation that can cause a boiler flame to go out has to do with the way burners are arranged to support combustion. As this simplified diagram illustrates, burners are usually positioned one above the other. When operating normally, the flames from the burners converge near the center of the furnace. With this arrangement, the flame from each burner helps support combustion on other burners. Here, for example, the bottom burner helps support combustion of fuel from the middle burner, and the middle burner helps support combustion of fuel from both the top and bottom burners. If fuel flow to one burner is interrupted and the flame goes out, it may cause a loss of flame from other burners. In this example, if the middle burner flames out, it can't help support combustion on the top burner or the bottom burner. The result may be that the top burner and bottom burner also go out. In situations where coal is difficult to burn, lighting off igniters or warm-up burners can be used to assist the combustion process. Using additional igniters or warm-up burners is a typical approach to avoiding a loss of flame, especially when there is a potential for the flow of fuel to be interrupted. Now, there are other situations that can lead to a loss of flame that the operator will not be able to anticipate. A typical example is a boiler tube rupture. Now, boiler tubes are subjected to both the intense heat of the furnace and the high pressure of the boiler. On occasion, a tube may rupture, blowing water and steam into the furnace, superheater, or economizer section of the boiler. Depending on the location of the rupture, it may endanger the boiler flame. Ruptures in the furnace area of the boiler are usually the most critical. Ruptures in the area of the secondary superheater may also cause a flameout, while a rupture in the area of the primary superheater and economizer will not usually upset the boiler flame. When a boiler tube ruptures, water or steam is released into the boiler under high pressure. If the rupture occurs in the furnace area, it may extinguish the boiler flame. Since tube ruptures usually occur without warning, an operator must be constantly ready to shut off all fuel flow to the burners and purge the boiler of combustible.
In summary, boiler shutdown are critical for protecting the machinery and preventing accidents. Understanding the root causes, recognizing early indicators, and applying properly corrective action ensure safety and smooth operation. Always follow the precautions and use Marker's manual as your main reference. Proper knowledge, quick response, and strict adherence to procedures are essential for avoiding boiler failures.
Sir, tapos na po.